So today we'll talk about the cross field. Cross field is something like you have an E field and a B field. They are perpendicular to each other. So something like here, we can see the electric field is generated by these two plates. We have positive voltage here and negative voltage at the bottom plate. So we have a nearly uniform E field pointing to the downward, pointing downward. And for the magnetic field, it's generated by a coil. It's generated by a coil. I think, yeah. The magnetic field is set up by a means of current in a system of coils, but it is not shown here because the coil will be something like here, and if it's shown, then you cannot see the B field and E field. And actually, the B field is pointing into the page. You see the cross. If a charged particle moves through a region containing both electric field and a magnetic field, so we have a cross field, B and E field here, and then we generate a particle. And of course, it's a charged particle generated here, and then we have a slit. So only the particle going parallel to here can pass through it. If it is go or in this direction, it will be blocked by this screen. So make sure that the particle go through horizontally, and you will pass through the cross field. If the forces are in opposite direction, and especially the magnitude of these two forces are the same, then there will be no net force acting on this particle, and the particle will result in no deflection of the particle. So, and the next is the Hall effect. Hall effect is a bit more complicated. It's a dynamic process. So, as we discussed, a beam of electron in a vacuum can deflect by magnetic field, and then the drifting conduction electron in a copper wire also be deflected by magnetic field, which means that we have a wire here, and then the charged particle going from bottom to top, because we now know the moving particle is the electron, not a positive charge. But in 1879, the scientists does not know there are electrons yet, so they need this Hall effect allow us to find whether the charge carried in a conductor are positively or negatively charged. At that time, they may consider that the current is going from top to bottom, then there may be some positive charge going from top to bottom, not the electron going from bottom to top. But for this experiment, we call it the Hall effect. We know we can determine the polarity of the charge, and beyond that, we can also measure the number of such carrier per unit volume of the conductor. So in this case, so figure A shows a strip of a copper strip. So it has some width. The width is small d, carrying a current I, whose conventional direction is from the top to bottom. So the charge carry an electron. So now we assume the charge is really electron. It will be something like this. So as long as there are a charge which is negative, then the speed is going to the top. The speed is pointing to the top, and the magnetic field is go into the page. So V cos B is something like this and pointing to the left, and the particle is negative charge. So you minus, so you have Q V cos B is pointing to the right side, as shown in here, FB pointing to the right side. So something like this. And so there will be FB acting on this electron. So it will go to the right side of this strip. So actually, it will become, there will be a negative induced charge on the right side and a positive induced charge on the left side. In this case, for some times later, there will be a strong enough electric field pointing from the left to the right, like this. And also, this E field will act on the electron. And Q times E, and E pointing to the right and Q is negative, so FE pointing to the left. So as long as more and more electron going to the right side, the E field become larger and larger until FE equals FB. Then there will be no net charge acting on the particle. So in this case, there will be positive charge on the left side, negative charge on the right side, and then it will be an equilibrium situation. And actually, we can measure is that the Hall effect potential difference between the left side and the right side. So the Hall effect is a bit complicated. It's a dynamic process. So in this case, we can calculate like this. The voltage between the left side to the right side is V, and the E field is E, assuming it's uniform. And the width is D, so V equals dD, and QE equals Q VdB. Vd is the velocity of the electron, and Vd is J over Nd, as we learned it in chapter 26. So we have J equals I over A. So we substitute E equals VdB, and Vd equals I over NEA. So we substitute Vd into here, and then we substitute E into here. Then we can get N equals to Bi over VLE. L is the thickness of the strip thickness, which means that it is three-dimensional, but it is only a cross-section, so it has some thickness. And actually, A is the cross-section area, so L equals A over D. So we have D here. Okay, and actually we can find that V equals VDD. V equals VDD. When a conductor moves through the uniform magnetic field at speed V, the Hall effect potential difference, V would be something like this, where D is the width of the perpendicular to both velocity V and B. So any question for the Hall effect? Oh, actually, this is the density of the charge, and we can with this equation we can find the n, which is measurable, because we can know that okay, we have some charge here, so that it will generate some voltage. So any questions? Okay, so we have a sample example, a sample problem. A solid metal cube, we have a metal cube here, which is a square cube. The length of each side is small d, 1.5 centimeter, moving in the positive y direction, which means moving up on the figure, and at a constant velocity, 4 meters per second. The cube moves through a uniform magnitude field of magnitude 0.05 t, 0.05 Tesla, in the positive z direction, which keep phase at the lower electric potential and which is at higher potential. Electric potential because of the motion through the field, which means that we have a cube. We have a cube, and then moving up, and then there is a B field pointing to the C direction. What is the polarity of the left side? Polarity. Negative. Okay. Yes, exactly. So for the left side, it is negative charge. And for the right side, it is positive charge. Yeah, it's very simple. We cos B pointing to this side, so this side is positive, that side is negative. So the next one is what is the potential difference between the phase of the high and lower electric potential? So actually it's just V equals VBD. So it's simply like 4 times B is 0.05 times D is 0.015. So it is 3 millivolt. So this will be very easy. Just put all the value in the equation. Any questions? So a beam of electron is projected into a chamber by electron gun G, okay, the speed V. So according to the Lorentz force, it will cause the electron to follow a circular path, and actually using the Newton's second law of motion, this is a force, the magnitude of the force, and this is the central force to the particle, and MA is V squared over R, and actually we can calculate R to be something like this. It is quite simple. So we have a sample problem. An electron with kinetic energy 20 22.5 eV move into a region of uniform magnetic field of magnitude 4.55 times 10 to minus 4 Tesla. The angle between the direction of the electron velocity and between the direction of the particle and of the velocity and the B field the direction of the B field, I think, of the B field and the electron velocity Phi is 65.5. So here is the direction of the B field. And the electron velocity, what is the pitch of the helix path taken by the electron? The pitch is the horizontal distance between the helix line. So actually, we have the velocity equals to 2 times the kinetic energy over m and take the square root. So the kinetic energy is 22.5 times 1.6 times 10 to minus 19 over the mass of the electron is 9.11 times 10 to minus 31 and take the square root. So it is 2.81 times 10 to 6 meter per second. So P equals V parallel P. So V parallel is V cosine phi, and the period of the circular motion is 2 pi m over qb. So we plug in all the values, 2.81 mega cosine 65.5 degree times 2 pi times 9.11 times 10 to minus 31 over 1.6 times 10 to minus 19 times 4.55 times 10 to minus 4. So it will be something like 9.16 cm. Vertical pitch is this distance. So actually, this velocity contributes to the circular motion, and this velocity is a constant speed going in this direction. So actually, this distance is something like this velocity times the period of the circular motion, which means that if it is here, then it go something like this, go back. So the vertical distance between them is the pitch.
那那个 T 会给吗
T
这个周期
嗯
前面都没有。
嗯我再想想吧，OK so so for the next example, so the essential of mass spectrometer, which can be used to measure the mass of the ion. Actually, this one will generate the particle, and actually is an ion. So if there's an ion going to this slit, enter the cross field, and of course, not the cross field, not enter the uniform B field, and after it go into the B field, it will go through a circular path and hit this screen. Then we can measure the radius or the diameter, and what you like. X is the diameter of this circular motion. The initial stationary ion is accelerated by the E field. So we have an E field from here to here. There's a E field. So it will accelerate from here to this slit. And the potential difference is V, and of course V equals E times the distance. So the B field in this chamber is 80 millitesla, and the voltage is 1000 volt, and the ion of charge is 1.6 times 10 to minus 9 C. Strike the detector, and the point that lies X is 1.6 something meter. What is the mass of the individual ions in atom mass 1U? Actually, a proton or a neutron, probably a neutron, has a mass something like this. So first of all, we have something like delta K plus delta U equals to 0, which means the total mechanical energy are conserved. So the change for the kinetic energy is something like half of mv squared, and the change of the potential energy is qv equals 0. So we have v equals square root of 2qv over m. Now we have the radius, which is equals to mv over qb. So mqb, and we have v equals to 2qv over m on the previous page. So we can have 1 over b square root 2mv over q. So this is the radius, and of course x is 2 times the radius. So it is something like 2 over b and times the square root of 2mv over q. And actually, m will be equal to x squared b squared q over 8v. And we plug in all the values. 1.6, 5.2, 254, 254. 254 square times b is 80 milli. Q is 1.6022 times 10 to minus 9 over 8 times 1000. So the answer will be 3.339 times 10 to minus 25 kilogram, which will be 203.93 U. Okay, 5:45. So we'll continue 2 weeks later. 2 weeks later, we'll talk about the cyclotron, which means that I'll tell you how to disassemble your phone in the fastest way.